This is Dr. Canfield, and we're going to talk about correlation and regression. I hope you have taken at least a small break between all of the stats tests. Sometimes I think this subunit gets a little harder to understand conceptually if you aren't looking at data sets day in and day out. But y'all are smart, and more importantly, you guys work really hard. So you guys are going to get this. Correlation is with a continuous independent variable and a continuous dependent variable. What we're trying to see is if scores of the dependent variable consistently go up or down when the independent variable goes up or down. In a non-statistical talk sort of way, not using the official language, if you will, we're looking at consistency. Do scores consistently change? And a correlation, well, that correlation score tells us the strength of that consistency. Now, our correlation scores are called R scores. We use R, the lowercase r, to represent correlation. Scores can range from -1 to 1, and the closer to either end, the stronger the relationship. For example, an R score of -0.888 is stronger than a positive R score of 0.33. Remember, the absolute value is what tells us what is stronger. Now, whether the R is positive or negative depends on the direction of the relationship. As we talked about in the previous subunit, positive scores mean as the IV goes up, so do the DV scores. For negative, as the IV scores go up, the DV goes down. The positive or negative R scores tell us that direction and how strong or consistent the scores do this. Let's take a look at this table. The first thing we will look at is the top row. There are 7 different variables. Each one is an independent variable for our dependent variable, which is hopeful, how hopeful they are. Okay? This correlation table shows us 7 independent variables. Now take a look at the row with the lowercase r. Remember, lowercase r is correlation. This tells us how strong each independent variable is on the dependent variable of hopeful. Now, which is strongest, which is weakest? The strongest is feel good, the weakest is going to move. This means that scores for feel good are the strongest related to feelings of being hopeful, and the idea of going to move or feeling like you're going to move are the weakest when it comes to being related to hopeful. Now, what directions do they go in? They are all positive, which means as the score for each one of the IVs, that top row, go up, so does the DV, feeling hopeful, go up. Now let's take a look at the P row. This is for p-value, which are statistically significant, the ones that are all below 0.05. There are 5 independent variables in this table that are statistically significant. Which brings us to regression. Now, regression and correlation are related statistical tests. If an independent variable is insignificantly correlated with a dependent variable, it won't be significantly related in a regression. So if an independent variable is not significantly related to a dependent variable in a correlation, it won't be related in a regression, so we can eliminate it. That's why we always do a correlation before regression. Now, the easiest way I can think of explaining regression is that it predicts scores, and honestly, based on high school algebra. See, a regression model will give us an equation similar to using algebra. And using this, we can predict what someone will score. We have a b or a beta to act as their slope. So in our example, using those 5 independent variables that were significant, we can create an equation using their slope for those 5 that will give us a fairly accurate prediction of a hopeful score or feeling of being hopeful score. Finally, we do get what's called an R-square, and this is kind of a cool thing. It's the percentage of variance that can be attributed to the model, which means, in a less fancy way, this is the percent of change the independent variables create for the dependent variable. Okay, this is a regression table. In this table, B stands for slope, and P is the p-value. Take a look at which are significant and which are not. What's the strongest? It's the same as correlation, feel good. So we can create an actual equation to plot on a graph what scores we would have for feeling hopeful. So now check out the R-square. It's 0.440. This means that 44% of the change in hopeful scores is accounted for by these 5 variables. These 5 variables in the model account for nearly half of the variance in scores for feeling hopeful. So we can create an equation and pretty much guess what someone will score on a hopeful measure using these 5 measures. Now, these 5, successful at school, feel good, accepted, belong, and comfortable, those 5 together account for 44% of any change in the hopeful scores. So it is kind of a valuable thing to let us know what sorts of impact independent variables or multiple independent variables can have on a dependent variable.